This section is all about using several methods of factoring at once. It's hard to keep it straight, so here are your general rules. This may be a good thing to write in your notebook for tomorrow. The first thing we always do is factor out the greatest monomial factor first. Then we have some options depending if there are 2 terms in our polynomial, 3 terms in our polynomial, 4 terms, or if there already are some parentheses. If there are 2 terms in our polynomial right away, you're going to use the dose rule. If there are 3 terms, it could be a perfect square trinomial, or you may need to use the factor box. If there are 4 terms, I would start by trying the factor box. If that doesn't work, you may need to factor by grouping. If there are already parentheses there, that means you need to factor by grouping. Whenever you think you are done with factoring, make sure that you check the factors at the end to see if you can keep factoring. Many times students forget that 2 terms inside their parentheses could use the dose rule. It's usually what happens. Okay, we need to determine what way of factoring can we use in this problem. Well, to start, the easiest thing to do is first factor out the greatest monomial factor, which this one has something in common to all. I believe it's 3 and n. That needs to be factored out first. Now I'm left with a trinomial, 3 terms. Could it be a perfect square trinomial, or should I use the factor box? If I look at what's here, though this is a perfect square, this one is not. So I'm going to use my factor box. I can put in the 2n squared and the minus 9 first. I need to determine what 2 factors here get me to -7 there. Now I'm looking at those 2 numbers. They multiply to be -18n squared, and they add to be -7n. I believe the factors I am looking for are a -9n and a +2n. I can now fill in the rest of my factor box. So 3n times 2n minus 9 times n plus 1. My last thing to look for from the previous slide right here, always check your factors at the end and see if you can keep factoring. Look inside parentheses. Nothing squared, I can no longer factor. I am done. This polynomial factors to this. This polynomial has 4 terms. That means my options are either to use a factor box or to factor by grouping. Regardless, I need to first take out the common monomial factor. That's why. What I'm left with, I think I'm going to throw inside of a factor box. So let's go over here and see what those factors may be. Remember, when you're using a factor box to do 4 terms, you need to keep them in order. I went left to right here. I'm going to double check. X squared times x is x cubed, -1 times x is -x, x squared times 5 is 5x squared, -1 times 5 is -5. So it looks like I have the correct factors. Let's write out what I have now. My last step always is to double check that any factors I wrote down can still be factored. This one right here causes a problem. This is fine, but this one is a difference of perfect squares, dose rule. So I'm going to do y. I'm going to change that factor, this one right here, into x, x, 1, 1, with a plus, with a minus. Now I'm done. Let's consider this polynomial now. Well, there's two terms that only leads me to use one rule, the dose rule. But before I use it, make sure to take out the common factor. This now is the dose rule, so I split it up into two factors with the a in front. Square root, one with a plus, one with a minus. Check your factors to see if anything else is squared or factorable. I'm done. Let us consider this polynomial to factor. It has three terms. That either means I could use the perfect square trinomial rule or the factor box. Let's take out the common monomial factor first before we consider which one to use. All of these are divisible by 2 and have an x squared. In addition to just those two, though, they are also negative. I'm going to take out a negative 2x squared. If ever the first term of your polynomial is negative, take out a negative. It will make your life a lot easier. That being said, what I have left over will be a positive x squared, a positive 6x, and a positive 9. Before I jump to using the factor box right away, I notice that these two are both perfect squares. So let's check for the perfect square trinomial rule. Is this term twice the product of these? Yes. So I have a PST. I'm going to rewrite the 2x squared in front. PST rule uses only one set of parentheses with a squared. What goes inside? X plus 3.